For function notation, we're going to take this part here, g of 4 is equal to 8, and we're going to plug those numbers into our function to solve for a. So 8 is our output, which goes on the left, and 4 replaces x. We take 4 squared to get 16. We subtract 24 from both sides, and we divide both sides by 16. We get negative 1 is equal to a. Next up, they give us an input of negative 4, but they don't give us the output. Now that we have solved for a, we can figure that out though. So we write it like this: g of negative 4 is equal to our a value, which is negative 1, times our new input, which is negative 4, squared, plus 24. So g of negative 4 is equal to negative 1 times 16 plus 24, which is equal to negative 16 plus 24, which is equal to 8. They try to confuse you because you'll notice negative 1 is one of your answer choices. That's not the final answer though. If you stop there, you'll get it wrong. This next problem is nearly identical. The numbers are different though. We begin by plugging in 6 for x and 7 for f of x. 7 is equal to 3 over 2 multiplied by 6 plus b. Hopefully my 6's and b's are distinguishable. This gives us 7 is equal to 9 plus b. 6 times 3 is 18, divided by 2 is 9. If we subtract 9 from both sides, we get negative 2 is equal to b. From here, we're going to use our new input, negative 2, and our b value, also negative 2, to find out what f of negative 2 is equal to. So 3 over 2 times negative 2 minus 2. Or in other words, negative 3 minus 2, which gives us a negative 5, and that's your final answer. Again, we see that negative 2 is one of your answer choices, but that's not the final answer. That's what b is equal to, not the value of f of negative 2. On the back, at the top, we plug in for x, negative 3x. So this becomes negative 2 times negative 3x plus 5, or 6x plus 5. For this table at the bottom, they want to know for which value of x is w of x plus t of x equal to x. So we add together these rows, and we say, is negative 3 plus a negative 1, 1? The answer is no, it's not. Is 1 plus 4, 3? No. Is 3 plus 3, 4? Nope. Is 5 plus a negative 1, 5? The only one that this is true for is this row here, because w of x, which is 3, and t of x, which is negative 1, when you add them together, you get x. And they want to know, what is the x value when this happens? The x value when this happens is 2. Imaginary numbers, the first problem. They tell us that I is equal to the square root of negative 1, which is true, but it's pretty irrelevant to this problem. All we have to do is combine like terms. 7 and negative 8 are both numbers or constants, where the 3i and the 9i are both I. We combine these. 7 minus 8 gives us negative 1, and 3i plus 9i gives us 12i. Oftentimes there will be a minus between these two, and you'll have to distribute the negative. That's not the case here. It's just 7 minus 8 and 3 plus 9. For the second problem, we want to cancel out the denominator. And to do that, we're going to multiply by something called the conjugate. So you take 3 minus 5i and divide that by 8 plus 2i, just as written. And we're going to multiply by a fancy version of the number 1. 8 minus 2i divided by 8 minus 2i is still 1. It's just a different form of it. And how did we get this? We took the bottom number, 8 plus 2i, 8 stayed the same, and We made the 2i the inverse, negative 2i. From here, we're going to use the box method twice. On the left, we will multiply straight across the top. 3 minus 5i from here, and 8 minus 2i from here. This gives us 24 minus 40i, negative 6i, and 10i squared. This represents the top of our fraction. Now let's multiply the bottom. We have 8 and 2i, 8 and negative 2i. I'm multiplying straight across the bottom. 64, 16i, negative 16i, and negative 4i squared. The reason why we chose minus 2i and plus 2i is so that this would happen. Our I terms cancel out, which makes the problem much easier to solve. So let's simplify these and then we can start to build our fraction. We have 24 minus 46i plus 10i squared, and we have 64 minus 4i squared. I squared is equivalent to negative 1, so we can replace that. Everything else stays the same, but instead of I, we're going to use a negative 1. We multiply, and this becomes plus a negative 10, and this becomes plus a positive 4. So when we combine like terms, we get 14 minus 46i, and we get 68. Remember, the left is the top of our fraction, and the right is the bottom. So let's go ahead and rebuild it, dividing it by 68. You might notice that all of these numbers are even, which means we can divide them all by 2. That simplifies the fraction, and it becomes 7 minus 23i divided by 34. And you'll notice the only difference between this and our answer, which was letter C, is that they have split the fraction into 2 parts. The problem on the back is solved in a very similar way. We begin with 8 minus I and 3 minus 2i, and we multiply by the conjugate. 3 plus 2i divided by 3 plus 2i. Later on, when we do the area model, these i's on the bottom will cancel out, and this will give us just a number which will allow us to write it in complex form. Let's use the box method twice. Here on the left we have 8 and a negative I, 3 and a 2i, all this is coming straight across the top, 3 minus 2i, and 3 plus 2i. Box method is set up. We have 24, negative 3i, 16i, negative 2i squared, 9, negative 6i, 6i, and negative 4i squared. So remember, our I squareds are replaced with a negative 1. So this gives us 24 plus 13i plus 2, because it's a negative 2 times a negative 1. And on the right, we have 9. The i's cancel out, and it becomes plus 4, because negative 4 times negative 1 is a positive 4. If we simplify this a little bit, we can rebuild our fraction. If we were going to split it, we would have 26 over 13 plus 13i over 13. We could reduce this quite a bit, but we don't need the whole answer. Out of the form a plus bi, we only need a. So what is 26 divided by 13? It's 2, which is our answer.